Okay, example number 2. A key-off account. This is a type of retirement fund that you can open up if you're self-employed. So Robin, who is self-employed, contributes $5,000 a year into a key-off account. How much will he have in the account after 25 years if the account earns interest at the rate of 4.5% per year, compounded yearly? So I'm going to use the calculator for this example. So I'm going to enter in some information here. Well, I'm going to write down some information on my paper. All right. And then I'm going to plug in the information into my calculator. So let's see here. All I'm doing is just copying on my paper what I see on my calculator screen there. And again, how did I get here? How did I get here? Go to apps, 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 and then enter finance, enter TVM solver. There we go. All right. So payment's always going to be at the end. I'm not going to even worry about writing that down. All right, let's see what we have here. So N is going to be what? Well, it's being compounded yearly, and he's putting it into the account for a total of 25 years. So N is 25, okay? It's really 1 times 25 because that would be your M value. M would be 1 for yearly, and then 1 times 25, T, would be 25. So look, this number is the total number of times that a payment is being made, which is the same as the total number of times the interest is being compounded. Okay, that number is going to be the same. All right, interest rate, 4.5%. You just enter in 4.5. Don't change it. Keep it exactly the same. Present value, it's not a present value. It's a retirement account. So present value will be 0. Payment, make it a negative 5,000 because it's money that you're, that's leaving you going to somewhere else. Future value, I'm going to put an asterisk there. That's what we're going to be solving for. And these last two are going to be the same. It's compounded yearly. So what's that mean? Compounded yearly. That's just once per year, okay? Payment 1 time per year, compounded yearly. So all I got to do now, is use this application. So N's 25, enter in 25. I is 4.5. Present value is 0. Our payment's negative 5,000. Go down here and change payments per year to 1. Make sure compounded per year is also 1. And then go back to future value. And what do? You hit alpha and then enter to solve. Okay, alpha, enter, and there you go. So that's your answer. Let's write that down. $222,000, $222,826.05. Just round these to the nearest cent again. All right. Example number 3. So Karen has been depositing $150 at the end of each month in a tax-free retirement account since she was 25. Matt, who is the same age as Karen, started depositing $250 at the end of each month in a tax-free retirement account when he was 35. Assuming that both accounts have been and will be earning interest at the rate of 4% per year compounded monthly, who will end up with a larger retirement account at the age of 65? So here again, you could use the formula if you want, but I prefer to use the application. All right, so let's look at Karen first, and then we'll look at Matt second. All right, so for Karen, what would we enter into our calculator? Again, if you want to use if you want to use the formulas, that's fine. In fact, I'll show you. If you use the formulas, this is what you're going to get. That's the answer right there if you want to look at it. Karen will end up with a larger retirement when she turns 65. This is the formula route. If you'd like to do it the formula way, there you go. So you can pause the video now, take a look at that if you like. The way I like to handle this problem, though, is again using the calculator. So let's figure this out. We have N, we have I%. We have present value, which is going to be 0. Payment. Future value is what we're solving for. And then payments per year, compounded per year. Okay. We'll do the same thing here for Matt. And let's see here. Future value is what we're solving for. Payments per year, compounded per year. All right. So for Karen, N would be what? Well, this says since she was 25 and we're going to 65, how many years is that? From 25 to 65, that's 40 years. And she's depositing it monthly. So that's going to be number of times per year. M is 12. Number of years, T, would be 40 years. Okay? What's the interest rate? Well, for both of them, it's 4%, right? So that's going to be 4. Might as well put a 4 here. Payment, well, Karen is depositing $150, so negative 150. Future value is what we're solving for. Again, the payment is monthly, which means she's compounding it monthly as well. These two things will be the same, all right, which we've talked about already before. Let's go to Matt. Matt, who's the same age as Karen, started depositing $250, so his payment's negative $250 in the application. But he started it when he was 35. So how many years is it from 35 to 65? That's 30 years. So he's still making payments monthly, but he's only doing it for 30 years. He's making a larger payment, but let's just, again, ultimately see what the time value of money is in this specific situation. All right, so let's look at Karen first. Karen, we're going to do N is going to be 12 times 40. Hit enter. Interest rate's 4. Payments negative 150. That's what we're solving for. So we have all our numbers plugged in there. We go to FV, future value. And what do we hit? Alpha. Enter. Let me write that number down. Whatever that number is. So future value for her is $177,294.20. Okay? And then we change some things around for Matt. So I go up go to N for Matt, and what does Matt have? He has 12 times 30. He was investing for 30 years. Interest rate's the same. His payment's negative 250. And everything else looks good. So go to future value, and then hit alpha, enter, and there you go. So his future value is $173,512.35. Okay, so who will end up with the larger retirement account at the age of 65? Karen is the big winner. This is more money than that. All right.